Good evening, everyone. Yeah, we are talking about data structure using Java. So in last class, we have completed stacks and the queues. The syllabus, if we go through that, we completed block one, and then block two, we completed two data structure we completed, and three data structure we completed. I'm looking forward to the next data structure is hashing and EP. Next data structure is hashing and EP. I'm sharing the notes. We look at this. This is we are talking hashing and AP was block three. Facilitate. Now, what is hashing? You see, and before coming to a before coming to hashing, so why we are going to discuss about hashing, we have to discuss about little drawbacks of the previous techniques, like linear search and binary search. Look at this. So there are two. The examples here is the several searching techniques are there. Linear search, binary search, search trees. The several techniques are there. Now these techniques are like linear search and binary search. The drawback of these two search algorithms is when the number of elements increases, when the number of elements are increases, the time taken to perform the search also can increases. Time taken to perform the search also increases. Now this becomes problematic when total number of elements become too large. When your search is having a too large of elements, so finding or searching a element in the pool of large elements, it takes more time. The search time takes more time. Now to overcome this, we have one more technique called hashing. So we also call it as hashing data structure. This hashing is also called a data structure. It is a very popular technique. So here it minimizes number of comparisons while performing research. It minimizes the number of comparisons while performing the search operation. The, the what is an advantage of this technique is it is very efficient than the previous two techniques. So it is very efficient than the previous two techniques. And the time taken to perform the search is, it doesn't depend on the total number of elements. So at least bother about the total number of elements. So it completes the search with constant time complexity. So how that mechanism works is, how this mechanism works is, how this mechanism works based on the hash table. So which is an array data structure, the hash table, which is an array data structure, it stores the data items. Here, the items nothing but elements you can call data elements. You can take any elements, you can take your data elements. These are data elements. Okay. Now, based on this hash key value, the data items are inserted into the hash table. So nothing but this, we call it as a key value pair. There is a key and there is a value. So this is called hash table. Nothing but this is called hash table. That's called key value pair. Okay. So it is an array data structure. It is an array data structure. So what is the purpose of this is it will store the value. It stores the data items here, nothing but the values. It stores the values. Now, if you look at this, the hash key value is special value that serves as an index of the data item. Here, this is an index, nothing but hash value. It's nothing but hash value. So hash key value is a special value. This is a special value. Okay. It serves as an index for a data item. So what we said, it's an index. It's an index means it pointing to the value. The index value points to the direct value which is stored under that. Now it indicates where the data item should be stored in the hash table. Now if you take this is an hash table, if you take this an hash table, so this hash key, it points that where the hash value to be stored in this hash table. So to store it here, to store it here, to store it here, where the hash value to be stored in this hash table is directed by this hash key value. This is hash key. That nothing but you can call index value. This is also called index value. This is also called hash key. Also called hash key. Now see here, there's an hash key. Now the hash function is a function that maps any big number or a string to a small integer value. What is the job of the hash function here is, the hash function job is it takes the element as an input. It takes the element as an input. So here, this is the element input to the hash function. This is called input. This is called input. This is called input. So hash function takes the data item as an input and returns a small integer value as an output. It returns small integer values as an output. Integer value as an output. Now the small integer value, we call it as the hash value. The small integer value, we call it as the hash value. Now you see here, let's say this is an integer value, this is an integer value, this is an. So this is an hash key. This is an hash key. This is an hash value. This is an hash value. This is an hash value. Now the hash value of the data item is then used as an index for storing it into the hash table. The hash value of a data item is then used as an index for storing it into the hash table. So here hash key contain hash value. By using the hash value, it can store the data in the hash table. So there are some types of functions also available here. There are some types of functions also available. There are some functions also available here. Now see here, the types of functions here. The types of functions here. So one function is mid-square hash function. The next one is division hash function. Next one is folding hash function is there. Mid-square hash function, division hash function, and folding hash function. Now it depends on the user which hash function you wanted to use. So the mid-square hash function can be used, or division hash function can be used, or folding hash function can be used. So which hash function to be used? It depends on the user. Depends on the user. Now, the properties of the hash function. What are the properties? The properties are this hash function is efficiently computable. So we can computes very efficiently, and it minimizes the number of collisions. So there will not be less number of collisions, and it distributes the keys uniformly over the table. Means an entire table, the keys are very uniform, distinct keys. That means no duplicate keys. It doesn't maintain any duplicate keys. So every key is unique. Every key is unique. Every key is unique. Now see your example we take here. The problem is here, the problem we take using the hash function. The key mode 7 insert for these values. Insert these values and use separate chaining technique for the collision resolution. Now first step is we draw the hash table, empty hash table. We draw the empty hash table. This is an hash table, empty hash table. And the given hash function, the possible range of hash values are 0 to 6 because it is 3, 7 values are given. So the range, the index value is 0 to 6 because now the index starts from the 0 to 6. This is the first step. So we draw an empty hash table and which contains 7 buckets. Which contain the 7 buckets. So 0 to 6. And next one, insert the given keys in hash table. We have to insert the hash value one by one. The first key to be inserted in hash table is 50. Here the value is 50 here. And we have to insert the first value 50. So which contains the bucket table contains 50. That is 50 mod 7. That is 1. So the 50 will be inserted in bucket 1. Which of the hash table. The next one is after 50, what's the next value? It is 7. Now, the next key to be inserted in the hash table is 700. So that is in the 0th index. So like this in step 4, so like this, we insert the all values till we insert the all values till like this. So in step 8, we insert the all values. One problem you can take is more problem you can take the same problem you can take and with a different approach. Now here collision resolution technique can be classified. So it can classify separate chaining and open addressing. So it's called open hashing, this is called closed hashing. Separate chaining is called open hashing and open addressing is called closed hashing. Now under this open addressing, closed hashing we can call, there's a linear problem is there, quadratic problem is there, and double hashing is there. So in open addressing, those are separate chaining, open addressing. So all keys are stored inside the hash table. No key stored outside the hash table. Every key is stored inside the hash table. Every key is stored inside the hash table and no keys stored outside the hash table. No keys stored outside the hash table. Now the operations in open addressing. So the operations we apply here is insertion operation we apply. So under this insertion operation, the hash function is used to compute the hash value for a key to be inserted, and hash value is then used as an index to store the key in the hash table. So that is the insert operation. Now, in the case of the collision, in the case of the ambiguity or duplicate, this will collision. So the probing is performed until an empty bucket is formed. So once an empty bucket is formed, the key is inserted. So that is the probing is performed in accordance with the technique used for the open address. So that is the search operation. To search any particular key, to search any particular key, to search any particular key, its hash value is obtained. Its hash value is obtained. Its hash value is obtained using the hash function used. Now using the hash value, now the bucket of the hash table is checked and the required key is formed. The key is search. The key is search. The other way, the subsequent buckets are checked until the required key or an empty bucket is formed. So the empty bucket indicates that the key is not present in the hash table. Is not present in the hash table. So this is the search operation. This is the search operation. Next one, delete operation. Now to apply the delete operation, the key is first searched and then deleted. Any value to be deleted from the hash table, so it has to be searched first. It has to be first search the value and then delete next. Now after deleting the key, the particular bucket is marked as the deleted. So for deleting, you have to mark the particular bucket as deleted. So that is the delete operation. Now we discussed under the insert operation, search operation, and data operation. Now next coming to the open addressing technique. Next kind of technique is open addressing technique. Now, which is used for open addressing, linear probing, quadratic probing, and double hashing. Linear probing, quadratic probing, and double hashing. Now, first we'll see linear probing. See linear probing. So when this linear probing will occur is when collision occurs, the linearly probe for the next bucket. Now it is easy to compute. The advantage is it is easy to compute, and the disadvantage is the name problem with the linear probing is clustering. What is the problem with the linear probing is for clustering? So many consecutive elements it forms groups. That takes time to search an element or to find an empty bucket. So the nearest elements or consecutive elements will form a group as a cluster. That is a problem with the linear probing. Now here the time complexity count as a burst time to search an element in the linear probing. So big O of table size. Now because there is only one element present and none of the elements are deleted, the deleted markers is present in the hash table and makes search the entire table. This is linear probing. Next, quadratic probing is that collision occurs with inputs pi squared the bucket in ith iteration. So we keep probing until an empty bucket is found. So that is quadratic probing. The double hashing. So when we use another hash function, that is 2x, we call it as, and look for I multiply hash 2x bucket in ith operation. It requires more computation. It requires more computation time as two hash function needed to be computed. So that is linear probing, quadratic probing, and double hashing. So in this primary clustering is supported by linear probing, and the primary clustering doesn't support by quadratic probing and the double hashing. Whereas secondary clustering is supported by linear probing, quadratic probing, and the secondary clustering doesn't support by double hashing. The next one factor is number of probe operation sequences for anticiple size of table. The next operation is cache performance. The cache performance in the case of the linear probing is best, and in the case of the quadratic probing is it lies between two. And in the case of double hashing, the cache performance is very poor. So it concludes that linear probing has the best cache performance but suffers from clustering. You see, linear probing is best cache performance, but it suffers from the clustering. Suffers from the clustering. Now, quadratic probing lies between the two in terms of cache performance and clustering. And double caching has poor cache performance but no clustering. So that is the next one is low factor. The next one is low factor. The next one is low factor. The load factor alpha is defined as number of elements present in the hash table by total size of the hash table. Let's make a formula this. Number of elements present in the hash table. Total size of the hash table. In open addressing, the value of load factor always lies between the open addressing, the value of load factor always lies between 3 points. Now, this is because in open addressing, all the keys are stored inside the hash table. All the keys are stored inside the hash table. So size of the table is always greater or at least equal to the number of keys stored within. Practice problems based on these addressing are can take same problem what we taken earlier. This we already discussed collision resolution technique and separate chaining versus open addressing. Separate chaining versus open addressing. The keys are stored inside the hash table as well as the outside the hash table. In the case of separate chain, the case of separate chaining. Now, open addressing, all keys are stored only inside the hash table and no keys present outside the hash table. This is in the case of open addressing. The case of open addressing. Now, in the case of separate chaining, the number of keys to be stored in the hash table can even exceed the size of the hash table. But whereas the number of keys to be stored in hash table can never exceed the size of the hash table. Case of open addressing. That is open addressing. And the separate chaining, deletion is easier. Separate chaining, deletion is easier. But whereas in the open addressing, deletion is little difficult. Deletion is difficult. In the case of separate chaining, extra space is required for the pointers to store the keys outside the hash table. Extra space is required for the pointers to store the keys outside the hash table. And no extra space is required in the case of open addressing. Now, in the case of separate chaining, cache performance is poor, and because of linked it stores the keys outside the hash table. So when it stores the keys outside the hash table, obviously the performance impact. But in the case of open addressing, cache performance is better because you have no linked list are used. You have no linked list are used. Some buckets of the hash table are never used, which leads to wastage of space. Some buckets of the hash table are never used, which leads to wastage of space. Now, in the case of this, buckets will be used even if new key match to those particular buckets. Now, these are the differences. These are the differences between separate chaining and open addressing. Now, which is preferred technique then? The performance of both technique depends on the kind of operation that are required to be performed and the case stored in the hash table. In the case of separate chaining is little advantage when it required to perform all the operations and the keys stored in the hash table. There's insertion operation, deletion operation, and searching operation. The searching operation. Now, in the case of open addressing is advantage When request to program in insertion operation and search operation. It requires to perform only insertion operation and search. Now, so these are the hash function. These are the hash function. Now coming to priority queues, coming to priority queues, just a minute, into priority queues. Now this we completed hashing, this we completed hash function, hash table with the worst case, this one. Then hash table without linked lists. Then hash table with worst case. Then it's called hopscotch hashing. Now this is an open addressing hash table. It's an array of buckets and stores at most one key value paired in each bucket. The open collision hopscotch hashing aims to keep key value pairs close to the original bucket. So that is and inner slashing and extendable hashing is also there. And the performance of the hash table generally depends on the hash function having two fundamental properties. So one is the hash function must be computable in constant time and independent of the number of items in the hash table. The hash function must distribute its items uniformly among the array cells. In particular, if the hash function is poor, then all bets are off. Then coming to the priority queues, that is the heaps. Now, in this, the objective is binary heaps and heaps, the applications and types of heaps. The two topics we'll discuss under this. Now, the objective of this is we understand what is a priority queue, we understand how to implement the binary heap, and we describe the applications of the heaps, and we describe even the binary types of various types of heaps, various types of heaps. Now, The introduction to the priority queue is, so any job sent to a printer are generally placed on a queue. Generally placed on a queue. Now, this might not always best thing. Example, one job might be particularly important, and so it might be desirable to allow that job to be run as soon as the printer is available. Now, conversely, when the printer becomes available, there are several one-page jobs and one-page jobs. So it might be reasonable to make the long job last. Even if it's not the last job submitted, unfortunately, most systems do not do this. Now it's going to be particularly any time at a times, nothing at times. So here, several processes to run. A process is allowed to run only for a fixed period of time. So one algorithm uses a queue and jobs are initially placed at the end of the queue. Now the schedule repeatedly takes the first job on the queue and run it until either finishes or its time limit is, and place it at the end of the queue if it does not finish. But the static is generally not appropriate because very short jobs will seem to take a long time because of the wait involved in run. Generally, it's important that short jobs finishes as fast as possible. So these jobs should have precedence over jobs that have already been run. Furthermore, some jobs that are not short are still very important and should also have precedence. So what exactly the priority queue is a priority queue is a new abstract data type, which is collection of prioritized objects as elements that allow arbitrary element insertion and allows the removal of the element that is first priority. When an element is added to a priority queue, the user designates its priority by providing an associate key. The element with the minimal key will be next to be removed from the queue. There's an element with a key. One will be given priority over an element key 2. So understanding it. So although it is quite common for priorities to be expressed numerically, so any Java object may be used as a key as long as there exists means to compare any two instances A and B in a way that defines natural order of the keys. With such generality, applications may develop their own notion of priority for each element. So example, different financial analysts may assign different ratings. That can be star mark, that can be 1, 2, 3, that can be any kind of ratings it is. So here, a particular set, such a share of stack, a priority is a data structure. A priority is a data structure that allows at least the two operations. At least two operations. At least two operations. That is insert, which adds element to the associated key, and the delete, and which finds, returns, and removal minimum elements in the priority queue. The insert operation is the equivalent of an queue, and delete minimum is the priority queue equivalent of the queues. So these are the priority queues functions. Priority queues functions, that is insert, main function, and the remove main function, size, and incentive. Now insert, if you take, it is in lowercase, it must be lowercase. That is k comma b stands here key value pair. So which creates an entry with key k and value b in the priority queue. So this function, what does this function do is it creates an entry It creates an entry with K and value V in priority. So min function returns but does not remove a priority queue entry with a key value pair K comma V having minimal key returns null if the priority queue is empty. If the priority queue is empty, it returns null. Returns null. And remove min function removes and returns an entry having minimal key for the priority queue and returns null if the priority queue is empty. So this is the remove main function. Main function, what is main function does? Main function returns a priority queue entry with a having minimal key. So it requires minimal key. And if it is empty, it returns null. And remove main function is doing what? It having minimal key from the priority queue and returns null the priority queue. The size function returns the number of entries in the priority. Number of entries in the priority queue. Now, is empty returns a boolean indicating whether the priority queue is empty or not. Is empty. Is empty the function. That means this function is checking the boolean value. Returns the boolean value true or false. So with that boolean value, it indicates that whether the priority queue is empty or not. Now, how does this implementation of the priority queue implemented? The priority queue will allow any type of object to serve as a key. Here you can take the object, you can take any object. Here any type of object means the object can be any. It uh, can be a vehicle, it can be any type of object it is. It can be some kind of product, it can be a car, it can be two-wheeler, any kind of object it is. So it serves as the key, but we must be able to compare keys to each other in a meaningful way. So here, the result of the comparison must not be contradictory. The comparison tool to denote by D to be self-consistent, it must be defined global order creation. Now, which is to say that it satisfies the following of properties. Any keys K1, K2, and K. K1, K2, and K2. Which are having comparability property and antisymmetric property and transitive property. The comparability property states the comparison rule is defined for every pair of keys. This property implies the reflexive property and next one is binary heaps or heaps. Binary heaps or heaps. A binary heap is a heap. So a tree which obeys the property that the root of any tree is greater than or equal to all its children. The primary use of such data structure is implemented for pairwise. Here the binary heap is a binary tree, a tree which each node has at most two children, which satisfies the following additional properties. The binary tree is complete that every level except the bottommost level is completely filled and lots of the bottommost level are positioned as left as forward. So max property, the key of every node is larger than or equal to string. Here the max is, now if you look at the binary tree, it does not enforce any ordering between the sibling nodes, which also means the completeness of the tree ensures that the height of the tree, the height of the tree, a binary heap is in which every node is similar, every node is smaller than or equal to their children is called mean heap. The binary heap is heap, in which every node is smaller than or equal to the children is called a mean heap. So here max heap is one simple implementation is to store a list in memory. With the left child of every node number to the parent of any node is, so to understand this, look at this. So this is an insertion to begin with, the so when the key index is increased, the leaf is still smaller than its parent, then it's okay. Otherwise, exchange the key with its parent key. The two totaling of control of key reaches a position with the insertion. So insertion, we append the value at the end of the binary tree and then float it up. So as long as necessary, this exit is the same as the index. The output will the building heap. Building heap is now simple. All we do is repeatedly insert keys, starting with the empty, starting with the empty. Talking about there is a better way we shall that we better is complexity. Both these operations at the worst will traverse the full height of the tree. So taking we go from building a heap as what are the applications of the applications and types of heap? So one application is selection problem. The next one is event simulation. And types of heaps are one is for D heaps. Next one is lattice heaps. And this means queue heaps. Queue heaps. Next one, the nominal queues. The manual queues. The next concept is sorting. Next concept is sorting. On this sorting, we discuss about insertion sort, shelf sort, matrix sort, and quick sort. Discuss about insertion sort, shelf sort, matrix sort, and quick sort. What quick sort? That is to understand what is insertions are. Okay, after studying this, we understand what insertions are, and we understand how to implement the shells are, and the square, the matrix are, and the fix are. These are. Now, sorting array of elements is an art. Now, to simplify the things, we will assume in our example that the array contains only integer, although code will once again allow more single options. In our entire study, we'll also assume that the entire sort can be done in main window, so that the number of elements is relatively small, less than a 2 million, and the sorts that cannot be performed in many memory and must be done on these these per tape are also quite important. Now, this type of sorting, known as the external administration of information sorting, show that it's really easy algorithms to sort without input, such an insertion sort. Like there's an algorithm shell sort. It's very simple, and so they are slightly more complicated sorting algorithms, single purpose algorithms, which requires comparisons. So remaining sortings, insertions are the implementation with Java code. Next, we'll see merge sort, big sort. You see all these sorting techniques in the next class. See all these sorting techniques in the next class.